Hi, I'm Brian, and this is the next video in the series on code generators. This time, we're going to talk about code generating, both active and passive, really in the context of your SDLC, in the context of CI/CD, and delivery, and artifact storage. So a quick refresher, we've got people and bicycles and we've got, shareable models now. So we're sharing some models that come from some repository somewhere. And we're referencing some templates that came from other places and we're putting it all together and we're generating some really neat output. Where does this fit, right? Like when do we do this when we build software? So if you remember in the beginning, we talked about, major category active versus passive software generators, code generators. uh, Active being we use it a lot, we use it over and over again, right? Passive being we use it once and we generate a lot of stuff and then we start making changes to it. Generally speaking, what you'll see is the biggest sort of bang that you can go after in the passive generator, right? So project scaffolding is the big one here, right? Like how much of a project can I sort of create? How much metadata can I get through there automatically? There's a lot of head start, there's a lot of value in that consistency. But then the next one is once you have that scaffolding, where inside there are you doing this kind of work? And when you do it, what happens to the results, right? Like what happens to this Java code? What happens to this Python code? What happens to these SQL scripts? So we'll make some assumptions. Make some assumptions that you're using source control, or make some assumptions that you've got some continuous integration running. So you've got a build process. And then we're going to talk about, archiving artifacts, right? And like, how does that impact this referencing? So in your SDLC, the first thing you're going to do is probably, again, passive generation. You're going to generate a project structure. And it's got some source code and it's got some docs. Maybe it's got a README. We'll talk about Markdown, by the way, right? Like a bunch of code generators in this space. So there we've got this thing. We're going to commit this code. Life is good. Now we're going to go put some models in here, right? So maybe we'll put our models in /models and we'll put a couple in there and then we'll put our little code generating stuff in here. And, practically speaking, there's two ways to do this. One of them is follow the golden rule, which is never check in any generated code. That works given that you have a couple of things working really well related to CI and packaging and artifact distribution. So ideally, we're going to take our project. Right? We're going to commit our repo. We're going to commit our branch. And we'll put that in source control. We're going to have a build. And part of build is going to be a code gen that makes new source code. Right? So we're making new code over here. And now we're actually going to do a real compile, package, test, all the stuff you do, right? Now we're actually going to take these packages and go check them into artifact storage. Right? So Artifactory or S3 or somewhere, and we're going to put version numbers on these. So now what we've got is code generation, but ultimately what we're producing is library somewhere that you can immediately refer to from other contexts. So if you don't want to check in source code, this is a great way to do it. It doesn't hurt much if you check it in, right? Like sometimes there's a big repository, there's a lot of generation going on. You generate it all, you check it, you run a bunch of integration tests or unit tests, you commit it all together. It's going to get built all into one big package. Like it's not the end of the world if you don't set this up and completely separate your generated code and your packaging. But this does have some benefits, particularly from a governance standpoint. If you've got multiple projects downstream, all using the same compiled result from these models, right? So a few like minor SDLC, CI/CD, like if you get this working and it's just generating your code automatically on the build server, you're never checking in generated code, there's a level of certainty and determinism that this is always running and you're always getting the right output into there. So some value like logically in getting this to work. But again, a little bit complexity on making sure you do. Next, we're going to talk about interface and usage. So how do you use your code generator? Normally, right? Like, and I mean, we'll do just a little bit of layering conversation. A lot of code generators are going to start with a CLI. So cookie cutter, velocity, Jinja, there's a CLI, right? Like all of them have some kind of CLI, usually wrapped around some library. So when we talk about extensibility and reuse, if you want to package your code generator, you want to package code generation inside your application, one of the things that might be interesting is where can you target the output? And do you have to target the output to a physical file system? Or can you target it to a bunch of strings? Or can you target it to a zip file in memory so that you can send it to somebody else? Or you put it in a string buffer so that you can run it over an API. There's a bunch of things you might do with generated code at runtime that mean that having it as a library that's got some separation from the CLI, there can be a lot of value there. Although, sort of not everybody does it this way. The other one, of course, then is there a user interface that is, pretty? We talked about visual modelers. Ideally, it's using the same library. Ideally, I can produce models from anywhere and send models in and templates in. So the more open this ecosystem is around this core code generating engine, which lets me do this, the better ability I'm going to have to embed it. I'm going to be able to use it in different places in my software delivery process as well as at runtime. So a little bit of consideration as you look at code generating tools, how many different interfaces are there? How universally do they work? And that covers the main subjects in code generators as an overview. I think we're going to give maybe details of template and sort of really look at some syntax options. I think probably the biggest thing here to note is you can really tell, I talked a lot about how the models and the shape of the models, what you put in them versus what you put in the templates, like it's highly related to the structure of the output that you're interested in. So, better models here that are more complicated, more well thought through, end up giving you the ability to sort of generate more generalized outputs. So what becomes interesting when you look at the templating languages is if the templating language, so we're going to take Jinja, right? Jinja's default delimiter character in the templating language to insert variables and do control flow is brackets, right? So brackets are control statements in Jinja templates, primarily because they're used to generating Python and Markdown and SQL and everything but Java, right? Because Java is a brackety language. And if you're going to generate lots of brackets, your templates, you probably wouldn't want to use brackets as the escape character, or you'd be escaping them all over the place. So your templating language, like if you look at Velocity, Velocity is a Java-based templating language, and they use a different delimiter sequence than the bracket because you're trying to generate a lot of Java with Velocity. So you're outputting brackets a lot. So sometimes you can tell just by looking at the templating language, like you'll be able to tell which engine it is, but you'll also be able to get some insight into what the authors were thinking about in the choices that they make here about reserved characters and structure. So that largely covers code generators. The next thing we're going to talk about is, a specific subclass here around SQL models.